Hi fellow mathematicians, you're welcome to John Calculus Maths class. Today we are having this brilliant integral which we are asked to integrate 2x plus 1 over square root of x squared plus 6 plus 5 dx. So you can pause the video if you want to try it yourself. So in this integral we will observe that we'll be using the method which is called completing the square method to evaluate this integral. So now when we observe by our completing the square, we'll be using our denominator which is x squared plus 6x plus 5. So because we have to find a factor that we can fit into the square root to substitute our integral. So watch as we do it. Now from our denominator which is x squared plus 6x plus 5, let me just bring it out. X squared plus 6x plus 5, so which is equals to x squared plus 6x plus, I'll bring my bracket, my 6 over 2, and this I will square it, plus my 5 minus 6 raised to the power of 2, that is 6 times 6, will give me 36, all over 2 raised to the power of 2, 2 times 2 will give me 4. Now I'll bring my bracket and I have my x plus my 6 all over 2, then I square it, then minus 5 times 4 will give me 20, 20 minus 36 will give me minus 16, so I have my minus 16 over 4. You can see. Now in this side, now I'll bring my x. Now 6 can divide 2, it will give me 3, so I have x plus 3. Remember a square, I have squared, minus 16 divided by 4 will give me 4, so this is 4. Now this one is equals to this, so therefore x squared plus 6x plus 5 is equals to bracket x plus 3 to the power of 2 minus 4. You can see, so we'll find the complete square of this. So this one now we'll just fix it into our square root so we can substitute this integral. So by my original integral, I'll bring it like this. In my integral, 2x plus 1 all over, remember all of this is equals to this, which I have my bracket x plus 3 to the power of 2 minus 4, because when you factorize for this you end up getting x squared plus 6x plus 5. Don't forget my dx. Now in this side, now we'll be using our substitution method to evaluate this integral. So I will say let u equals to x plus 3. Let u equals to x plus 3, and I have my du equals to, now in this side the derivative of x is 1. We can say 1 dx, but the best we'll just leave it as dx. We'll put my dx. Derivative of 3 is 0, so we don't have to put that one. Now remember, from your numerator here we are having x here, so we have to solve for x so that we can obtain something like this. So we have to solve from x from this place here. We'll just say let x be the subject of the formula. By doing that, my plus 3 will just cross equal to return to minus 3, which I have my u minus 3 equals to x. U minus 3 equals to x. So let me clean this. How can I continue from here? Let me just do this like this. Wow, nice. So now I'll bring my integral. So I have my 2. Now where's my x? My x is u minus 3. I'll put my bracket u minus 3. Then we are having plus 1. I have my plus 1 all over my square root. Now remember in my square root we say let u equals to x plus 3. So where my x plus 3 is u, I'll put my u. Remember it is raised to the power of 2, so I'll now put my 2 here, which is u square. Then remember we're having minus 4. Then we will now have, then what's my dx? My dx is nothing but du. So here will be du. So now let me come to this side also. I'll bring my integral. My 2 times u will give me 2u. 2 times minus 3 will give me minus 6. Minus 6 plus 1 will give me minus 5. I have minus 5 all over square root of u square minus 4 du. Now in this side now, we have to split our integral into 2, which is like this. My integral 2u over square root of u square minus 4 du. Then my minus sign, minus 5 over square root of u square minus 4 du. You see, we split our integral into 2. So now we have to evaluate for each integral. So let me call this my IA, and let me call this my IB. So I'll be starting from my IA first, which is my IA is equals to my integral 2u over square root of u square minus 4 du. Now in this side now, I'll be using my substitution to evaluate this integral. So I'll say let v equals to u square minus 4. Then I have dv equals to 2u du. Then I'll have my dv all over 2u equals to du. You can see equals to du. So I have my integral, which is 2u all over. Now remember, my u square plus 4 is nothing but v. So I'll fix it into, I have my v, which is square root of v. Then I have my bracket. Remember, my du is dv over 2u, dv all over 2u. Now observe, we have 2u here, we have 2u here. So both of them are the same, so we cancel them. We'll cancel them, okay. We continue from here. So we are left with dv all over square root of v. Now in this side now, it's same thing as having it like this, v raised to the power of minus 1 over 2 dv. 1 over 2 dv. So we are integrating for this, which is v raised to the power of minus 1 over 2 plus 1 all over minus 1 over 2 plus 1. I have to put my constant. So I've taken away my integral out. So 2 times 1 will give me 2, minus 1 plus 2 will give me plus 1, which I have v raised to the power of 1 over 2. Same thing in this place again, 1 all over 2, which is equals to, now when division turns, it becomes multiplication. Then my 2 will go up and multiply my numerator, which is 2v raised to the power of 1 over 2 plus c. Now we have to substitute back our v. What's our v from our substitution here? Our v is u square minus 4. So I have my 2 bracket u square minus 4. Remember, it's raised to the power of 1 over 2 plus c, which is equals to, now I'll just, my 1 over 2 now will square my u square over u square minus 4. My 1 over 2 will just square it. The same thing as having like this, 2 square root of u square minus 4 plus by c. So remember, this is nothing but my IA. Now we'll evaluate for our IA. Now remember our IB. Now we have to solve for our IB also. So let's do it in this place. Now remember, what's our IB? Our IB is nothing but, so remember we have negative sign. Let me bring my negative sign. Then 5 all over square root of u square minus 4 du. Now, in this place now, in my IB, I'll be using my trigonometry identity to evaluate this integral. So I will say let u equals to let u equals to 2 sec theta, because we'll have 4 here. This square root of 4 is 2. This is it here. So, and I have my du equals to, now derivative of sec theta is nothing but, remember my 2 here, derivative of sec theta is nothing but sec theta tan theta. Sec theta tan theta, then I have my d theta. I'm going to write it clearly. 2 sec theta tan theta d theta. You can see d theta. Then for my denominator, I have u square minus 4. Now my u square, now I will remember my u is equals to 2 sec theta. And remember in in this place we are having u square. So when my 2 fall into this u, that is 2 times 2 will give me 4. And when my sec theta falling into this u, that is sec theta times theta will give me sec square theta. Sec square theta. Remember we have minus 4 and minus 4, which is equals to, so this is same thing as having like this 4 bracket sec square theta minus 1. You see, is equals to 4. This is my 4 here. Now sec square theta minus 1 is nothing but tan square theta. Remember, is multiplied by 4, that is 4 tan square theta. Now I'll now bring out my root, my square root of u square minus 4. Now when I put all this into my square root, then when I simplify it, it will be nothing but 2 tan theta, because my square root of 4 is 2, and my square root of tan square theta will give me theta, because I've taken away my square. Then we'll bring our integral. Remember, we're having 2, we're having minus, don't forget your negative sign, my negative sign, then my 5. I bring my 5 to multiply. Then what's my du? For my equation, my du is nothing but 2 sec theta tan theta d theta all over. Remember now, from our denominator here, d is it here is nothing but 2 tan theta. Now I have my 2 tan theta. You can see. Now my 2 will divide my 2, my tan theta will cancel tan theta, 2 cancel 2, tan theta cancel tan theta, because they are both the same. So we are left with 5. So let's move on in this side. So I have my minus. Then let me just take my 5 to the back of my integral. I have my minus 5. Now, since both of them are cancelled, remember we are left with sec theta. Then we have sec theta d theta, which is equals to, now the integral of sec theta is nothing but minus 5. Remember my minus 5 here. The integral of sec theta is nothing but ln bracket sec theta plus tan theta plus c. Because I've taken away my integral, so I have to put my constant sign plus c. Now what do we do here now? Remember, we have to substitute for this one also, my sec theta. From my substitution here, what is my sec theta? My sec theta will be u over 2. Let me just show us. Remember, u equals to 2 sec theta, and we are asking to find sec theta. So we just divide both sides by 2 like this. 2 cancel 2. Remember, we are having sec theta equals to u over 2. So that is for my sec theta. Now I have my, which is equals to minus 5 ln u all over 2 plus Now my tan theta is nothing but square root of u square minus 4 all over 2 plus c. Now this is equals to my IB. You see, this for my IB now. So what are we doing next now? We have to combine both of them together. Remember, my IA is 2 square root of u square minus 4, and my IB is nothing but minus 5 ln u over 2 plus square root of u square minus 4 over 2. So we are combining both of them together, which I have for my IA, I have 2 square root of u square minus 4. Don't forget a negative sign, minus 5 ln my u over 2 plus my square root of u square minus 4 all over 2 plus c. Yeah. So let's clean this side for more space. Now we substitute back our u. See, substitute back u. Now remember, from our first substitution, remember our u is nothing but x plus 3. X plus 3. So anywhere I see u, I'll put my x plus 3. So for my first one here, I have 2 square root of x plus 3. Remember, I have raised to the power of 2. I have my 2 here minus 4 minus 5 ln. I have my x plus 3 all over 2 plus my square root of x plus 3. Remember, I raised to the power of 2 minus 4 all over 2. Don't forget your constant sign plus c. Now I have this will be nothing but 2 square root of. Now when we solve for x plus 3 raised to the power of 2 minus 4, we will finally have this one as our original factor here, which is x square plus 6x plus 5 minus 5 ln. So this side is now raised to the power of 2, so we'll just leave it like that, x plus 3 all over 2 plus x square plus 6x plus 5 all over 2, then my constant c. Then although we've gotten our final answer, but there's a nice way we can put it to look more good. So I'll say 2 square root of x square plus 6x plus 5 minus 5 plus 5 minus 5 ln. I'll put my bracket minus 5 ln. Now remember, this we have both number in the denominator, so I can leave it like that. I can say 1 all over 2 bracket x plus 3 plus square root of x square plus 6x plus 5 plus 5, then my constant sign c. So these are final answer to this brilliant integral. I hope you enjoyed the solution. Wow, it's a really nice integral to tackle. Thank you very much. Once again, this is John Calculus Math Class. Please don't forget to like, comment, and share this video. Thank you.